What if you could 3D print everything you needed on the moon? Well, I'm here at Startup Fest 2025 in Montreal, Canada, and I'm speaking with Madison Feehan, the founder of Space Copy. Space Copy is a technology company that allows you to extract whatever materials you have around you and then use those materials to print whatever you want. She ultimately wants to print on the moon, but in the meantime, she's got more earthly endeavors like things like the Arctic and other places around the world. We talk about the fact that she's managed to get a bunch of pre-orders, but she needs some capital to actually fulfill them. So would be interested to hear your take on her business and where she's at. Over to you, Madison.
Hi, Madison.
Hi.
Thanks for joining us today.
Thank you.
Why don't you tell everybody what you do with your time and who you are?
Absolutely. So my name's Madison Feehan. I'm the CEO and founder of a 3D printing and manufacturing company based out of Alberta. It's called Space Copy. And we are sending 3D printers to the moon.
To then print.
To then 3D print
Because I can send one to the moon, but it doesn't do anything. Got it.
Yeah, we're creating infrastructure for astronauts. We have dual use tech. It's applicable here on Earth to building up infrastructure for remote communities.
That's cool. So let's start with the moon stuff. So what are you proposing? You have a shovel and you dump it into the printer and then it just prints with moon soil, moon dust?
100%. It's moon dust or lunar regolith, the more tech term for it.
Yes.
It is very much ceramic based. Ceramic manufacturing has been around for 4 decades. We got a bunch of heritage we can leverage off of. We are 3D printing whatever you need when you need it. Rapid deployment, everything from precision tools to housing to roadways and launch pads, pipes, beams, berms, over 250 items 3D printable with locally derived materials, whatever you can find on the ground.
That's super cool. So when we were originally talking about this, you mentioned that there's also a prep phase. It's not just the print phase. There's you have to get it ready to prep.
Oh yeah.
Print, and that's part of the technology. Yeah.
Oh yeah. It's a 4-stage process.
Okay.
The first stage is what we call material processing, or more tech term, beneficiation. So you're crushing, you're mixing, you're sieving down.
I'm going to be very smart after this conversation.
Exactly, right? Yes. We're all going to be rocket scientists by the end of today. And this is not just because I did used to work for NASA.
Yeah.
But no, critically speaking here, we break down the rocks into a powdery-like substrate. We do material characterization. That's the second phase. So it's like a little laser beam. It scans and tells you what the composition is that you're looking at. What are you working with? What's this made of? And then we 3D print with it, any kind of structure that you need, over 250 items again. And we've got 2 different systems. We've got one that extrudes out of almost like cement-like slurry for rapidly deployable large-scale infrastructure. And then we've got a little laser melting system for the really fine, precise tools. And then last but not least, AI-based, fully autonomous, 5-axis robotic arm built in with custom QA that's going through edge computing, custom machine learning algorithms. It's an end-to-end modular system so that there is as little maintenance and interference being done by the people with the boots on the ground.
How is AI involved in it?
It is, again, fully autonomously built system. Mm-hmm. All of the different subcomponents of hardware, the material processing, the 3D printing, the quality analysis, that's all being based off of algorithms that are carrying out those tasks independently.
Okay.
We're training the material data. We're training the robotics on what pathway it needs to go to.
It's not doing decision making. Is
it? It does to do some decision making to figure out if that part meets the kind of quality standard for the end user, and whether that end user is in mining or energy or aerospace. We have to figure out, what are the bottlenecks and the pain points, and calibrate that with whatever AI algorithms are being outputted by our machine, making sure that makes sense for the use case.
But if it's bad, if the materials for some reason doesn't meet the criteria, like it's dirty or polluted or something like that, does it eject it? Is it a little ejector tray and it's no, try again?
Yeah, we got some slag material that can be outputted if it's really bad.
Yeah.
For the most part, though, we're pretty darn good at using just about everything that there is.
That's cool.
And then do you
have to make your own chips as well, or are they off the shelf chips to do? You said there's some hardware.
Yeah. Off the shelf.
Most
definitely.
Oh, okay. That's cool.
Some of the secret stuff, we build some of that sauce in-house,
yeah.
If you will, and then a lot of it is taken off the shelf and then just reverse engineered, modularized, and then ruggedized.
That's super cool. And so how long have you been building this for?
3 years now. We're coming up on our third birthday.
Wow.
But yeah, I was conceptualizing this idea back in 2017 for 3D printing on Mars.
Right.
And then, somewhere along the lines of working for NASA and going to Harvard Business School, taking entrepreneurship and international business, I was like, there's a use case for this.
Right. But it's not like we don't go to Mars yet.
No.
We kind of go to the moon, kind of again, sort of. We kind of forgot. We kind of remember. How do you get it to that point? Do you need to go to market? You said northern communities. Is that hey, maybe there's a practical use case. We need to test it, obviously.
Oh,
But
yeah.
I'm assuming, do you want to sell it before? Like, are you just going to fundraise until you go to space, or you want to actually have real world use cases?
Everything you said, we're doing a little bit of each.
Okay.
So yeah, space-based, that's 5 years out. It's practical, but in the interim, we are a corporation. We need to generate revenue. So we've got our first printer system that's being sent out to Resolute Bay, Nunavut next year. So getting into an Arctic environment, do some field testing. It's actually going to be at an astronaut analog test base. So doing some simulated space conditions while also being in a really kind of ruggedized extreme Earth environment. And we've got 300 units on pre-order for all sorts of different B2B clients. So we're looking at attacking this from the let's get printer units made and sold.
Right.
But at the same time, catch-22, we got to get some funding into the company in order to get those first MVPs out to those clients.
So what's the use case in the Nunavut? Like, what is it actually supposed to be doing? Like, I imagine in space, the most obvious thing is like building housing and tools and all that other stuff.
Same.
Same
It translates way over. Weirdly, door hinges seem to keep breaking up in Nunavut. So
Really?
that and vehicle repair parts, legacy equipment as well. So things that have broken down that are no longer manufactured by the OEM.
Yeah.
You can remanufacture that. I think what I really like to highlight is we're doing this 70% cheaper and 20% faster than standard logistics.
Sure.
And the more extreme your environment gets, if it's a natural disaster or combat zone or just a really traverse environment that you don't want to be in when you have lives on the line, that's where the tech starts to make sense.
Got it. I mean, it goes without saying that, like, the key point here is the materials. You have 3D printers that you can use now, but being able to use whatever's around you is the thing. But what you said, you have 300 pre-orders. Is there a pattern around what the vertical or the kind of company that's looking? Is it door companies? Like, who wants this on the planet Earth?
Weirdly, a lot of those pre-orders are coming from aerospace companies, but they're coming from space companies that have dual use tech focuses. So whatever they're building also has applications on Earth. So our tech would be still used in the terrestrial ecosystem. Take the energy industry, for example. 3D printing battery support structures in the desert is a really interesting use case that we found.
Really?
Yeah.
Because they can't ship things easily? Like, what's the...
Things break down easily. You need a lot of consumables, and it's already a really hard environment to get stuff into. If you're not sending stuff up on a chopper on a regular basis, which in itself is expensive and hard to do, then you're probably not having a very good business model and you're losing out a lot of momentum. So by having something that's on site that's just printing that rapidly, a new support structure every hour or two, as opposed to every 6 to 8 weeks, it makes a big
It's
fundamental
really interesting because, like,
difference.
3D printing made a sort of their big splash with the MakerBot in like 2014
Oh, yeah.
kind of universe. And everyone was like, well, clearly you don't need to buy anything anymore. We're just going to print everything. And it sort of, there was the ebb and flow of that ecosystem. And now there's like tools like Bamboo, which are like iPhone of, like, you still have to get plastic and put it through the spools. But like that reality never materialized, pardon the pun. And it's funny because now we're like, in what you've created is clearly like, oh, actually, no, this can be commercially viable and actually used for real shit, other than like, I have a little hat that's made out of plastic or whatever. And you were saying that, like, how did you fund getting the technology to the point that it is now? Because it works, right?
Yeah, it does work.
So how did you do that?
We work with simulated moon dirt, volcanic soil, Arctic rock. What we did to date is all bootstrapping and non-dilutive funding. So NASA contracts, grants, incubators and accelerators, and then friends and family that invested in early, believed in the vision, got us, to the point where we could have operations in Canada, US, and Europe, and then get an MVP printer up and running.
Right.
And then now it's expansion on that growth, get a couple more MVP models for the people that are willing to pay for it now, raise a pre-seed, hopefully closing on that next month. And then the full seed round so that we can start, building out those 300 units, really start generating revenue over the next 8 to 12 months.
How, you don't have to give me the exact number if you don't want to, but like, is this like, was the money up to now is like $500,000, $100,000, $1 million? Like, was it, I just have no concept of how you build a new entire 3D printing ecosystem, because you're not building software, you're building physical things and you have to test with physical things. And I'm sure putting, sand has a whole bunch of different problems that grind up the gears than, dirt, than whatever.
Oh yeah, there's wear and tear to take into consideration.
And different materials have different attributes that ruin printers, I imagine.
Absolutely. 3D printing with lunar dust is much like working with shards of glass.
Got it.
Never a fun time. And we're doing something that's novel, right? Like nobody's doing this,
Right.
or hardly anybody's doing this, I
Yes.
should say. So we have questions that nobody in this world knows how to answer. So
You just like build this in your basement?
we
Like,
have
as a
university
lab?
labs. Yeah.
It's university lab. Okay.
So at least on the Canadian side, University of Alberta, York University, Concordia, University of Waterloo. On the American side, folks like MIT and Johns Hopkins and Colorado School of Mines, all people within our peripheral.
Got it.
And then also some private labs as well. But to answer your question, we run a really lean system. We're raising 5 million right now, and that is going to get us to that hopefully 300 units. But that said, it's an uphill battle.
Yeah.
And we're getting smarter about the way that we tolerate and handle things. And the more you iterate on the early prototypes, the easier it's going to be to build out of them and then just continue that pipeline.
But the first one was, you haven't, the friends and family and all this stuff, is not 5 million. 5 million is to build out all the,
To build out everything.
was
yeah.
it like, again, is it less than $1 million? Like, I don't know how you want to do this, but I just want to get a ballpark of like, how much does it cost to get to this point? Is it like
So we
order
did,
of magnitude?
yeah, we did 200K to date. That got us to this point.
That's it?
That's it.
That's
We run a
suspicious.
lean
Very
system.
suspicious. Did you print the iteration? Because that was to me, what I've learned from buying 3D printers is the entire ecosystem in 3D printers is printing parts for the 3D printers. That's what I think most of the models used to be. So to be able to fulfill those orders, you need the capital. Is that basically what you're saying?
Absolutely, yes. And then when we start fulfilling some of those orders, then that revenue just kind of turns over in itself, reinvest that back into more prototypes for more revenue and so forth.
Is there like a recurring revenue part of this, or once you buy the printer, like see it? Because I feel like
Oh,
it
yeah.
was like Bamboo, like we sell spools of ink or
Yeah,
plastic, and they're like,
we can't sell spools of moon dirt.
exactly.
We have two models right now that we're approaching. So we have the physical hardware sales, of course,
Yeah.
and then we have what we call a 3D SaaS, which is the recurring revenue model that we have. Renting out the units,
Okay.
or just having a subscription-based model for people that are looking at larger, kind of more commercial enterprise applications of multiple printer systems to fulfill their use cases.
Right.
So we have approaches from both ends of the spectrum.
Right. So where would you go? What's the first order you would fulfill? Like, is there like oh gosh, it's this vertical or this specific kind of customer that like we want that because it's either a ton of money or like we want to test a whole bunch of stuff with that kind of thing.
If I'm thinking of a capital perspective, there's some folks that are doing radiation shielding that are looking at buying a whole bunch of printers
Right.
because they need to 3D print paneling and they're working with weird materials. And then from the scientist perspective, getting to the heart of what we really want to do, there's some folks that are literally looking at this from a lunar perspective, or at least from a really, really rugged Earth perspective of weird and wacky materials. I talked a little bit about the Arctic test that we're doing next year. That's going to be done like at an analog astronaut test base inside of an asteroid impact crater where there's still asteroid materials and minerals
Crazy.
embedded into the dirt.
Right.
So the weirder the material gets, the happier we tend to be.
So how do you're in an interesting space because maybe your pedigree helps here, but like, how do you go to market with a non-existent 3D printer that people doesn't like? So not that it non-existent, but like a concept of a 3D printer that people probably never thought about before. How do you find customers? Do you put a thing on LinkedIn and you're like, yo, weird people want to print crazy things that I've never even thought of before? Because like the radiation thing, no one would think that. So how do you go to market with this?
I think it really comes down to knowing your audience. There's people that know about this that get it, and you start targeting those people first, and it's just a ripple effect. Word gets out. I mean,
Is it like scientists?
it is scientists
Is
like being part of like different consortiums of like NASA and Johns Hopkins University, like having those people within your circle. I mean, network is your net worth.
Yes.
Trailing that back to just like the overall broader scope of things. There's people that want tech for building on the moon who have space companies, and the only way that they can get investment is if they work with a company that's doing something that fulfills their criterion, and that's us. We're filling gaps for people. I think if you get kind of deeper into the weeds of space tech, 3D printing was done on the ISS for the first time back in 2013, so it wasn't yesterday. It's been 12 years.
Yeah.
There's demonstrations still actively going on for that. Last year, the European Space Agency sent up a big metal printing experiment. It was famous in the space industry. It comes down to knowing your audience, and then you build out from there, and you get to know people that are in mining and energy that don't even know what regolith is. What's moon dust? What are you talking about here?
Right.
And you start to really just sit down and say, okay, this is going to work for a really extreme environment in space. Of course it would work for an extreme environment here on Earth. Tell me more about you. Tell me what's your problem. And the more that we have those conversations, it just ripples out, and it's, hey, I know a guy who knows a guy, and all of a sudden you have a huge, huge clientele or partner or investor portfolio.
Yeah. How do you price a product that didn't exist before?
What are you willing to pay for it?
Of course, that is always the answer.
Well, I do tend to try and ask those questions, and also the questions of, if you had this tech, what could have made your life easier?
Right.
But we have different models. We have like the desktop, tabletop size model. We have the large model that can, 3D print like a cubic meter in size.
Yeah.
We've got, the classic extrusion, like cement slurry-like model for rapid deployment. We've got a laser model for really precise things like precision tooling. All those different things are priced differently. For the standard like desktop 3D printer that's doing like a cement-like slurry of extrusion, that's ranging from around 120 to 300,000, depending on how many iterations you're going.
Right.
And then, we build it very much customized to the end user, and however much tech they want to really dive into is what's going to reflect on that final costing.
And you've tried all these variants, like all these variants exist?
We've tried most of them.
Yeah.
We're still iterating on a couple different designs right now before we go ahead with the full launch. And we really only have one MVP, and then the rest of it, we're just taking, like off the shelf hardware and reverse engineering it as we kind of create our own systems.
Yeah.
Yeah.
So what, like 200,000 is not a lot of money. It just isn't for what it's kind of insane.
Yeah.
What's hard then?
What's hard about it?
Yeah. What's hard about it? Like, why can't I get $200,000? I'm using me as a stand.
Yeah, no.
I would buy fancy cameras. Why can't anybody just take $200,000 worth of money and build what you've done? Like, what is the hard part about building these kinds of printers?
People don't really know what it takes to be able to ruggedize something to that extreme. Like I talked about lunar dust being like glass.
Yes.
How are you going to 3D print with shards of glass? It
Yes.
takes so much science and so much knowledge, and that's the kind of expertise that takes years to build up.
Yeah.
Like you cannot go into this industry, even if you're in additive manufacturing and 3D printing, and know those answers. It takes a conjunction of knowledge pieces from business to deep tech to space science to 3D printing to be able to formulate that. And I think what it comes down to is when you really break down the subsystems, material processing, 3D printing, robotic post-assembly, AI, and combining all of that and doing it in a special way. I'll give you one example. We 3D print everything under vacuum. So, you can't take up tanks of nitrogen or argon up to space to 3D print under standard inert conditions. So we had to reverse engineer it. We had to do special iterations. And these are just knowledge pieces that people wouldn't think of.
Yeah. So you think it's fundamentally like understanding material science to an extent and understanding the variance and then engineering something that can handle all of the things?
Absolutely, yes.
Does it require, like from a maintenance perspective, I understand the idea is these things are ultimately autonomous and they robot maintain themselves, I suppose. But like, do you need special skills to maintain the machine?
I would say basic knowledge in 3D printing is pretty much all you'd need. We have support staff, as we're starting to roll out printer units in the next year or so that, if something goes wrong, of course we're on it.
Yeah.
But we're trying to build out these systems to be as independent as possible, have long, like 10, 15-year lifespans, really try not to have maintenance, use certain, coatings, for example, to prevent that wear and tear so that you're not having to run into those maintenance issues.
Interesting. So if you got like $5 million today, let's say I had a oversized novelty check under the table.
All right.
I don't. When would you be able to start shipping orders?
I'd say within 8 to 12 months. Like we want to take this time out to make sure that we really have ourselves, we've really gone through the weeds of figuring out what we need to do to make this work. Yeah. Like we have the prototype, but we need to run it through all those different kind of use cases. Like what's going to happen if XYZ occurs?
Yeah.
So yeah.
Have you ever like given it or thought about giving it to lending it, whatever you want to call it, to some, because as you said, a prototype or a lab is very different than it's in the desert and doing stuff. And maybe the answer is the Arctic.
That is exactly what I was going to say. The Arctic Mission. We're lending it to them.
In situ test of the.
Yeah.
But do you need to like test other, given what the profiles of your customers, like the door people,
Yeah.
Do you need to like, well, it's in a factory and it's very different than the Arctic, so we should probably test it indoor land. Do you think you need to do that first? Or like the Arctic test is probably enough?
I'd say you can do a little bit of triage prioritization and pick maybe 3 or 4 environments.
Yes.
That would be fundamental enough to get a conclusive nature of, what you need to do. Extreme heat, extreme cold, so desert and Arctic, and then microgravity. So we've got a test flight planned for end of 2026, beginning 2027 to get into a zero gravity environment.
Nice.
I'd say once we get through those 3 ecosystems, we'll think if there's anything else that we really need to critically think about besides, lab conditions.
Yeah.
And that would be conclusive enough in order to really capture what we're doing.
Cool. Well, that's a lot, but thank you for sharing it. If people want to find out more about the company, where do they go on the internet?
Well, first and foremost, spacecopy.com. You can find us on LinkedIn at Spacecopy, Instagram at Spacecopy Inc., or just come and find me. I seem to be everywhere at once. I'm thinking of 3D printing a few copies of myself.
That would be amazing and strange. Thanks, Madison. Appreciate you coming.
Appreciate the time. Thank you.
Thanks for watching. Subscribe to my newsletter in the description below, and see you next time.